Hello, my dear students. Welcome back to my channel. I am your mathematics guide, R.K. Nigam. Proceeding with the PYQs of CBSE Class 12 Mathematics questions, the chapter is Relations and Functions. Today, I am with a new problem which has been asked in CBSE Board Examination 2024. What is the problem? Let us see. Prove that the relation R in the set of integers Z defined as R is equal to the set containing ordered pair AB such that 2 divides A plus B is an equivalence relation. Also determine the equivalence class of 3. So what we have to prove that it is an equivalence relation. You must be aware that if the relation is reflexive, symmetric, and transitive, then that relation is called the equivalence relation. So first we will check for the reflexivity of the relation, whether this relation is reflexive. So we will check about that. We will check about the reflexivity, whether this relation is reflexive. So if we are able to prove that a comma a belongs to R for all a belongs to the set of integers, because this relation has been defined on the set Z of integers. So whether this is true, let us check. So what is the definition of the relation? If a is related to b, then 2 divides a plus b. So if we see what is a plus a, then a plus a is 2a, and definitely 2a is divisible by 2. 2a, because here is 2. So 2a is definitely divisible by 2. So we will write which is divisible divisible by 2, or you can also say that 2 divides 2 divides 2 divides a plus a is equal to 2a. So it is clear, and a is an arbitrary integer, so it is true for all the integers. A is an arbitrary integer. A is arbitrary, so it is true for every integer. That's why we can say that a comma a belongs to R for all a belongs to Z is true. So the relation is reflexive. It is the relation is reflexive. What about the symmetricity? We will prove for the symmetricity. Symmetricity. We will prove, check for the symmetricity, whether this relation is symmetric or not. So let us consider that a comma b belongs to R. That means what is the relation? 2 divides. If a comma b belongs to R, then 2 divides a plus b. That means we have considered that 2 divides a plus b. It is true. Then you can also say, if you write a plus b as b plus a, then there is no change. And because commutative law holds in the case of integers, so you can write a plus b and b plus a. And if 2 divides a plus b, then definitely 2 divides also b plus a. 2 divides b plus a also. So you can write that 2 divides b plus a also. For example, if 2 plus 4 is equal to 6 and 6 is divisible by 2, then 4 plus 2 is also 6 and 6 is again divisible by 2. So there is no change. There is no change. So that means we can say that 2 divides b plus a. In this way, with the help of this punch line of the relation, you can say that 2 divides b plus a. Here will be a plus b, then a comes first, uh, B comes first and A comes second, and B comma A belongs to R. So A comma B belongs to R, shows B comma A belongs to R. That means the symmetricity holds. Now, what about the transitivity? What about the transitivity of the relation? So for transitivity, we will consider that let A comma B belongs to R and B comma C belongs to R. In this way, with the help of this punch line of the relation, the 2 divides a plus b. So in this way we can say that 2 divides a plus b, and here 2 divides b plus c. So we will express this as a mathematical relationship, or you can say that a plus b is equal to 2m and b plus c is equal to 2m, because 2 divides a plus b, so it is expressible as a multiple of 2, and b plus c is also expressible as a multiple of 2. Now we have to find the relationship between a and c, whether a comma c belongs to R, that is a plus c is divisible by 2. So for this we add these two equations. So a plus b plus b plus c is equal to 2. Here you will consider k, so 2k plus 2m, or you can say that here will be a plus c, a plus 2b plus c, a plus 2b plus c is equal to 2k plus 2m, or you can write it that a plus c is equal to 2k plus 2m. Here is 2b, so transfer that 2b, and b is the integer, so there will be no change. A plus c is equal to 2 is common, k plus m minus b. So if k is an integer, m is an integer, and b is an integer, so k plus m minus b is also an integer, and a plus c is expressible as 2 into k plus m minus b, so it is also the multiple of 2. So you can say that a 2 divides a plus c also. This means 2 divides a plus c. That means a comma c also belongs to R. A comma c also belongs to R. That means the transitivity holds also. So this relation is going to be equivalence relation. It is proved. It is proved. You have to write in the board examination that as this relation is reflexive, symmetric, and transitive, that's why this relation is an equivalence relation. It is proved. It is proved. Now, what the other thing also determine the equivalence class of 3. That means which of the elements relates to 3. Which of the, so let us consider that 3 relates to B. Let us consider B relates to 3. So what is the equivalence class of 3? So we will check for the 3 comma B, that which elements, which integers B relates to 3. So that integers relates to B. If it is if it belongs to R, then what is the way? 2 divides 2 divides 2 divides 3 plus b, or you can write it that 3 plus b is expressible as 2n, as a multiple of 2, as a multiple of 2. So what about b? We have to check what is b. B is 2n minus 3, where n is an integer, and you know that what is the set of integers? What is the set of integer? It contains minus numbers, 0, 1, 2, 3. So in this way we will put, if you put 0 here, if you will put n is equal to 0, if you will put n is equal to 0, then you get b is equal to minus 3. B is equal to minus 3. If you will put n is equal to n is equal to 3, n is equal to 3, then you will put, you will get b is equal to 6 minus 3. 6 minus 3 is 3. So you are getting minus 3 here and 3 here, but you don't get 0. You will get minus 1 and plus 1. If you will put n is equal to 1, then 2 minus 3 is equal to minus 1, so you will get minus 1. And if you will put n is equal to 2, then 2 2s are 4, minus 3 is 1. So you get the odd integers here. You get the equivalence class relates to be as the odd integers. I'm going to write here. I'm going to write here. So what is the equivalence class of 3? The equivalence class of 3. The equivalence class of 3 will be the set of odd integers. That is minus 3, minus 2, minus 1, 1, minus 3, no, not minus 2, minus 3, minus 1, 1, 3. So these are odd integers. All odd integers will cover up in the equivalence class of 3, because b is expressible as 2n minus 3, and if you will put these integers one by one, then you get total odd integers, not 0, but total odd integers in this case. So this is the equivalence class which is related to 3. So this is all about the problem. I have discussed this problem thoroughly. Please write the theories where relevant, because I have not written all of the theories. You have to write that this relation is reflexive, symmetric, and transitive. That's why this relation is an equivalence relation. So wherever theory is required, you have to write theory in the question. So this is for today. Thank you very much.